enough compute and storage resources because we figured out like a relatively inefficient way, but we figured out a way to create intelligence. And ultimately, what we do is we are trying to just get more of these resources so we can basically amplify intelligence without having to amplify human lives. Now, the best way that we figured out how to do that today is basically building bigger and bigger buildings and trying to like organize energy inside of these buildings. But we are hitting limitations where basically like we cannot build larger buildings, and most importantly, we cannot find enough power relatively close to each other in these big buildings. Because as you start moving power and you start moving megawatts, you're losing a lot of energy on the way. So ultimately, we are hitting real limitations on how big these buildings can be and how much energy can we actually allocate in a particular spot. Now, if you look at what happened in the past 10 years in the context of silicon, we got much better. So back in 2017, we had a CPU using 200 watts that had 32 cores, and we have the same exact cores in the same GPU, but using 400 watts. But at this point, we are talking about hundreds of cores. In this case, 192. Well, at the same time, the cloud has done a particularly great thing. Of course, that's a joke, which is it kept the prices flat. So like if you had a digital ocean droplet back in 2013, it was basically $5 per core, and today it's still $5 per core. And the reason why this is happening is that big cloud providers basically have monopolies over the infrastructure. And basically, by owning the tooling, which is basically using these resources that are also procured by the cloud providers, they're able to keep our prices artificially high. And in that way, they keep the same price. Usually, like they would kind of like work together towards that. And the price doesn't change, even though like the fundamental price of executing that particular compute job is drastically lower. So just in this case, we should have seen like at least a 3-4x price reduction, but the price per core is still the same. And again, the reason for this is that most of the interactions which we have with the cloud today are basically dependent on the products that these cloud providers have built. This is AWS Lambdas, Kubernetes managed clusters, and a bunch of other things. All of these abstractions are basically built by the cloud providers, and we are forced to use resources basically sitting under those cloud providers. Very often for developers, that's kind of fine, because they would kind of avoid using a bunch of the infrastructure on the metal, which is like a pain if you're getting started with a small app. But usually what happens is that you get started super quick, and at some point, like you really hit like big cost constraints as you start scaling your app. Now, ultimately, the problem that we want to solve is we want to think about this uniform layer of storage and compute, which basically allows us to use any piece of silicon on the planet. So if you have a computer at home, which you usually use for gaming during the evening, that computer should be doing a particular workload while you're not gaming at home, and it should be basically contributing to this universal horizontal layer of compute. Now, we know a few things already in the context of crypto. We basically built like the largest compute network on the planet. Unfortunately, this compute network only does one thing, which is SHA-256. It does it pretty well, though. It's very distributed. It's very efficient, probably as efficient as those CPUs, but just specialized for executing just SHA-256. But what we've seen is that we are able to scale open networks to a point where no centralized provider is going to be able to scale. Now, what we miss here is we need to have a way of defining what is the job to be done. So in the context of Bitcoin, this was SHA-256. And in the context of computing, this can be many things. It can be storage. This is where Filecoin did a lot of work. It can be rendering. This is where the render network did a bunch, or encoding, where Lipier did a bunch. But ultimately, if you think about what these networks do is they define the workload and they incentivize the execution of that workload. Very little has been done outside of that. And we were able to actually build large networks that are doing this. Lately, you're also seeing like more GPU networks like Jensen that are focused on training larger and larger networks. But how can we actually increase demand? So for demand, it gets a bit trickier, because for demand, we also need to rebuild everything that the cloud providers have done. Ultimately, the cloud providers have built great tooling, but this tooling is really not compatible with the way that you would want to think about a compute workload in the context of decentralized computing. So a lot of the dev tools need to be built. And if you think about these different layers, where you have the apps, the tooling, and the infrastructure enabling this, in the context of Web 2, of course, like all of these were built, and they, of course, work super well. You could think of Facebook as the application layer, or Dropbox back in the days, and they would be using something like AWS under the hood. They would not be using AWS directly, which would be just the VM. They would be using abstractions like load balancers, Kubernetes managed instances, and so on. That's the layer that we're missing today in the context of decentralized computing. What's happening is we are seeing some abstractions that are basically trying to mimic what's happening on Web 2. So for example, in the context of Filecoin, you would see a lot of S3 compatible gateways. These gateways are basically acting as tooling that allows Web 2 developers to interact with the Filecoin network without having to worry about all the complexities that decentralized network has. But also, if you compare decentralized computing with DeFi, we are way behind. So in the context of DeFi, you had a bunch of the tooling like Tenderly, Truffle, and infrastructure providers like Alchemy, Infura, and so on. And very few of these are available in the context of decentralized computing. And yeah, like ultimately, this is a big friction that is kind of preventing us from growing and basically utilizing the resources that today are available. If you think about where we find today, it's basically we have super high incentives because these networks are really good at incentivizing the execution of a particular workload, but we don't have like the tooling that basically allows us to actually execute these workloads, and we don't have like all the apps that can be built on top of it. If you think about networks like open storage networks like Filecoin, you would see that just by using Filecoin, you can get a 10x cost reduction. And today, like we're just not able to benefit from that because the tooling does not exist. So yeah, ultimately, I want to wrap with this slide and basically invite everyone to build more dev tools. And yeah, thank you for your time.